So the area model or box method is called the area model because it's like you start with a rectangle and you want to get the area of this rectangle. But actually, when we're dividing, we would know the area and we're dividing to get either the length or the width. So either the left or the top. Usually, when we use this method for dividing, we want our answer on top. So before we use this method, we need to go back and remind ourselves what happens when we multiply using this method. So here is a random example completely separate to the question we're going to do for dividing. We're just going to use this to see how do we multiply. Well, here we have the length of this rectangle. It's an algebraic expression. And here we have the width. So to get the area, we would multiply those things together. But to make it a little bit easier, let's split it up into smaller rectangles. To get the area of this rectangle, we would get the area of each of the small rectangles first and then add them all up to get the full area of the rectangle. So if we know the length and the width, then to get the area, we have to multiply. So we're going to multiply to get the area of this box, multiply the length by the width, or the left by the top. So 3x times 2x squared, well 3 times 2 is 6, and x times x squared is x cubed. Just to get into the habit, let's go down, and then we'll go diagonally next, and then down, and then diagonally. So next we have 2 times 2x squared, which gives me 4x squared, and I'll just keep going along here, getting our answers to the areas of these. And we have all of the smaller areas. Now, because this is an algebraic expression, we can't add everything together. We can only add the like terms. So let's start with the top corner, 6x cubed. There's no other x cubes here, so 6x cubed can't add to anything. Now let's look at our 4x squared. Well, this has a like term, the 9x squared. So we can add those two together to give me 13x squared. So next we have to look at this 6x, and again there's another x term here, they're like terms, so we can combine those like terms. 6x minus 15x is negative 9x. And finally, this minus 10 is the only thing we have left. So, some important things to remember. This 6x cubed came straight from this top box. There was no like terms. The same with this minus 10. Came straight from that bottom box. There was no like terms. But all of the other terms, the 13x squared, came from adding the diagonals. And the minus 9x came from adding the diagonals. So when we want to use division, we need to remember those things. So now we have a rectangle on the right hand side, and we know this time that the area is 6x cubed plus 5x squared minus 10x plus 3. And we know that one of the sides has a length of 2x minus 1. As I said, we like to have the answer on top, so let's put the 2x minus 1 down the left hand side. So because that has two terms, I know there's going to be 2 rows. But I don't always know how many columns there's going to be. You might be able to figure it out, because if we divide an x cubed by an x, we will end up with an x squared. So there should be an x squared, an x, and a constant. So there should be 3 columns, but we can do this even if we don't know. So I'm going to start with one column first. Remember, this 6x cubed came straight from this box here. So this 6x cubed is going to come straight from that box there. Now we're working backwards, but I'm going to put that 6x cubed straight in there. I also know that this plus 3 had no like terms, so it should go in this bottom right box, wherever that is. But I'm going to do that later. So firstly, let's start by dividing. We know the area of this box and we know the width, so we can get the length, or we can get the top. 6x cubed divided by 2x. Well, 6 divided by 2 is 3. X cubed divided by x is x squared. So now I have the length of that box. That length of that box is also the same as the length of this box. So I can get this area now. 3x squared times -1 is -3x squared. Okay, now I'm a little bit stuck because I don't have enough information to get any more. But remember, this 13x squared came from adding those two x squared terms on the diagonal. So if I introduce another box here, these diagonals should add together to give me the x squared term. In this case, our x squared term is 5x squared. So if I have a -3x squared, what do I need to get to plus 5x squared? Well, the answer is positive 8x squared. Okay, so now I can go back to my dividing. 8x squared divided by 2x will give me the length, which is 4x, and that's positive. Now I can find the area of this box in the bottom. So 4x times -1 gives me -4x. And now again I'm a bit stuck, but my diagonals should add to give me the terms from the original polynomial. So this -10x. So this term and whatever goes in this box should give me -10x. So -4x and -6x will give me -10x. Now I can do the dividing again. -6x divided by 2x gives me -3. And remember we said that this box should have this positive 3 in it. If it does, it means it divides in evenly and there's no remainder. So let's check. -3 times -1 does give me positive 3. So that means there is no remainder. And we said our answer is the length, this term up here. So our answer is 3x squared plus 4x minus 3.